distinguished audience in Vancouver. I'm Xingyuan Ma. I'm going to present this demo paper, Reading Between the Lines, Image-Based Order Detection in OCR for Chinese historical documents. Here is the content. First, I will go through our research definition and background. Afterwards, I will talk about our system design and give you some demonstration of it. Then, I will talk about system analytic, and finally, the conclusion of our research. Chinese historical documents hold rich cultural knowledge. To safeguard this heritage, we must accurately decipher their content and their complex layout. That's why I'm presenting a specialized OCR system with a core focus on reading order detection. Traditional OCR system can struggle with the unique features of historical Chinese documents. A single reading order detection error can completely change the meaning of a sentence. Our system is designed to provide a robust solution for reading order detection, making future research on these valuable documents more accurate and meaningful. You can see this historical document contains complex layouts, calligraphic variations, diverse character sizes, and arrangements. These challenges make reading order detection a more complicated problem since they cannot be solved simply by sorting them in top to bottom or right to left order. Imagine deciphering ancient Chinese text, like this one, where characters stand across the page in columns, their sizes vary, and the flow can sometimes even curve with the age of the scanned document. Unlike modern, neatly formatted text, historical documents through unique challenges at traditional OCR systems. These systems can identify the characters, but putting them in the correct reading order becomes a complex puzzle. Calligraphic variations, intricate layout, and even subtle distortions during scanning can all create confusion. That's why our innovative approach, inspired by how humans intuitively grasp reading order, we've developed an image-based approach. This method makes it context-free, potentially applicable to documents with similar layout in other languages, for example, Japanese and Korean. Our system employs a three-stage process. Text detection. We utilize the differential binarization ++ model for its precision in locating text regions within the image. And then we do text recognition and reading order detection simultaneously. In text recognition, we applied robust SVTR-net, which handles text recognition within the detected areas. And when it comes to reading order detection, this is where our primary innovation lies. We leverage both raw image features and the spatial relationships between text blocks to infer the sequence. We model the ROD task as a pairwise learning to rank problem. Pairs of text blocks, along with corresponding raw image feature, are encoded using a convolution neural network, in this case MobileNet v3 small version, to compute a pairwise probability matrix. This matrix captures the likelihood of our one block preceding another. Finally, we employ the first decide and decode algorithm to efficiently decode the matrix and reconstruct the reading order. Let's see this in action. This is our system interface, which is simple and clear. The only thing you need to do is to upload images of documents. I'll upload a historical document image. And the system first detects the text area, and then it will recognize the text within and determine the reading order of this document. Let us wait a little bit. Now watch closely. Our system not only detects the text area, but also manages to recognize the text and reading order showing on the visualized image with text output on the bottom. Now I'm going to demo more images. More complicated ones will be shown later. Okay, you can see here, this is a more complicated one, since there are a lot of small and big texts within this image. However, our reading order detection works well on this example. To be noticed, because the different numbers of text blocks to be visualized in this in images. So the drawing image phase will depend on the text blocks it has. So it might take longer on drawing visualized image. However, the detection and recognition and the reading order part is known. So you can see here, this one is also a complicated one, but our reading order detection works well on this one. Now let's see a more and more complex one. Okay, see those intertwined columns and irregular spacing? Our reading order detection handle this intricate layouts, giving researchers a structured text output and reflects the page's visual context. However, you can see some text detection defects here. These defects will not influence the reading order detection since we do the pairwise reading order detection only. So this is also one of our advantage. Okay, let's talk about numbers because accuracy matters. Our system was evaluated using the MTHV2 dataset. That's 3,199 images with ground truth labels for text location, recognition, and crucially, reading order. Our system scores an impressive 95% F1 score in text detection, along with 83% text recognition accuracy. The real achievement here, however, is the 5% page error rate with our reading order detection model. To clarify, this means that our system correctly determines the reading flow for 95% of the pages in the dataset. These strong metrics translate to reliability and confidence for researchers to use our system. But the impact goes far beyond text extraction. Our system empowers scholars to decode not just the words, but the whole context in which they were originally presented. Here's our conclusion. You might think reading order seems like a minor thing, but it's actually how we unlock the way historical texts we meant to be experienced. Our system gets this visually. This image-based approach has exciting potential. While more testing is needed, imagine applying this to historical Japanese or Korean documents. That's the adaptability we are aiming for. Ultimately, this isn't just about upgrading OCR. We are bridging the world of digital research and ancient traditions. I truly believe this type of work ensures these historical records thrive well into the future. That is my presentation. Thank you very much.